Welcome to Healthcare Workflow Process Improvement, Quality Improvement. This is Lecture B. The objectives for this lecture are to describe strategies for quality improvement, describe the role of leadership in quality improvement, describe the local clinic improvement capabilities, describe and recommend tools for quality improvement, and compare and contrast the quality improvement methodologies and tools and their appropriate uses in the healthcare setting. This lecture provides an exposure to some major strategies employed in quality improvement. There is a significant amount of publicly available information and training on quality improvement methods and tools. We will not replicate these available resources. Quality improvement projects can be aided or impeded by the organizational culture. Regardless of size, any healthcare setting can improve the care it provides. It is important to understand the culture of the organization contemplating such improvements, work within it as necessary, and encourage the development or enhancement of the culture to support quality improvement. Leadership support and buy-in, the organization's ability to adapt to change, the communication ability of the staff in the organization, and the understanding of change or need for change by all involved are important factors affecting quality improvement. Factors needed for success include making quality improvement part of the job. Leadership support is essential for quality improvement activities to succeed. There are many ways leadership can improve the results of a QI project. Ransom et al. State that making quality improvement part of the job can raise morale, because staff and patients see that the barriers to care they face each day are being addressed, and they realize they can participate in the work to remove them. Ransom, 2004. They offer an example of adding discussions about quality and quality improvement to routine clinical management meetings. Involving everyone in quality improvement closes the gap that can exist between quality improvement teams and everyone else providing patient care. Healthcare leaders can create organizational culture that supports quality improvement. For example, leadership can assure that performance data is used to improve care for patients and can assure that it is not used in a punitive manner. Ransom, 2004. Ransom et al. Lists things that leaders can do to support quality improvement, including the following: creating and promoting a quality vision with shared performance goals. Increasing staff capacity to support quality improvement by training staff in QI. Training opportunities about QI should be available for all staff and part of their routine job expectations. Motivating staff to participate in improvement projects and encouraging them to make quality part of their jobs. Establishing a quality improvement team to manage this process, involving all staff. Demonstrating support of the use of metrics to measure performance. Making sure that the voice of the patient is heard and acted on through surveys, exit interviews, suggestion boxes, or other means. Involving staff and patients in decision-making, including QI in the budget. This exercise is to help you develop a context for thinking about quality improvement methods and tools. Identify an area in your life that you would like to improve, such as developing better study habits, giving up smoking, or eating healthier foods. Think through the challenges you will face, the factors that may influence your success, and the steps that you might consider taking to assure success. Pause the slides and jot down your thoughts on this personal improvement project. Pause the slides now. Think through the challenges you will face. Put these notes in a convenient place and use them to reflect on the adequacy of the quality improvement method and tools to address the challenges you will face, the factors that may influence your success, and the steps that you might consider taking to ensure success as we review the quality improvement methods and tools. The same challenges that you will face in making an improvement change affect organizations undertaking improvement changes. Organizations are, after all, groups of individuals. There are many methods for quality improvement. In this unit, we focus on process improvement that is human-centered and supportive of the implementation of health IT. For a more in-depth coverage of quality improvement in healthcare, an entire component, Component 12, Quality Improvement, is available. Ransom et al., in their textbook of healthcare quality improvement, present several strategies and associated tools for healthcare quality improvement. Among the listed methods and tools, you will find API, Baldrige, Focus PDCA, the IHI Breakthrough Series Model, ISO 9000, Kaizen, Lean Thinking, and Six Sigma. Ransom 2004. Quality improvement methods were originally tailored for enterprises, not necessarily healthcare. For example, Six Sigma was designed for manufacturing, but has spread to service enterprises, including healthcare. Each of these have met with success, but application of these methods in healthcare has also met with challenges. The API, Associates for Process Improvement Model, was developed by Tom Nolan and Lloyd Provost. The API model is a simple model, and like so many models for process improvement, it is based on Deming's PDSA, also called PDCA cycle. The API model uses three fundamental questions that form the basis of improvement. They are, what are we trying to accomplish? How will we know that a change is an improvement? And what changes can we make that will result in improvement? Focus is frequently on small improvements and on testing the results to verify improvement. An incremental approach that undertakes improvement through many small improvements to make big improvement. Like so many quality improvement methods, the Baldrige criteria were originally developed and applied to business. In 1987, the Malcolm Baldrige National Quality Award was created by Public Law 100-107. In 1997, healthcare-specific criteria were added. These criteria were focused on core competencies, new technology implementation, and sharing of electronic information, cost reduction, and alliances with other healthcare providers. These were organized into 7 interdependent categories: leadership, strategic planning, focus on patients, other customers and markets, measurement, analysis and knowledge management, staff focus and process management, and organizational performance, NIST-ND. Dr. Paul Batalden formed an internal consulting division for continual improvement called the Quality Resource Group in the Hospital Corporation of America in the 1980s. This group designed the Focus PDCA model, also based on Deming's PDCA cycle. Strickland, 2003. The model entails finding an opportunity for improvement, organizing an effort, clarifying current understanding of how the process works, understanding the process variations and capability, selecting a strategy for improvement, and using the Plan, Do, Check, Study, Act cycle. Test the strategy to determine if it results in improvement. Edward Deming derived what became known as the Deming wheel, Deming cycle, or Deming circle from Walter Schuert's 1939 straight-line, 3-step scientific process of specification, production, and inspection. Deming presented it as a circle to stress the importance of constant interaction among the 4 steps of design: production, sales, and research. The PDCA, Plan, Do, Check, Act cycle is often attributed to Deming and Schuert, but Deming has denied this connection. However, in 1993, Deming presented an evolved version of the cycle as the Schuert cycle for learning and improvement as a method for improving a product or process, and called it the PDSA, Plan, Do, Study, Act cycle. Moen, 2011. The International Standards Organization, in 1987, introduced the initial ISO 9000 guidelines for performance improvement. Components of these guidelines include: design and develop a QI program, create a socio-cultural environment and a structure that supports improvement, reduce or avoid quality losses, define QI responsibilities, develop an improvement planning process, develop an improvement measurement process, develop an improvement review process, carry out QI projects, and analyze the facts before you decide to do QI. Kaizen is a Japanese term for change for the better. The common English term is continuous improvement. The term connotes ongoing improvement involving everyone and assumes our way of life deserves to be constantly improved. It also includes improvement practices such as customer orientation, automation, and quality improvement. Lean thinking is a way to work more efficiently and effectively while providing customers with what they want when they want it. It is a philosophy and set of tools that aims to eliminate waste from processes. It also focuses on what adds value in processes from the perspective of the customer. The frontline workers are heavily involved in this approach. While the primary focus is waste, the outcomes of utilizing lean tools are efficiency, quality, and customer service. Implementation requires a commitment and support by management and participation of all the personnel within an organization to be successful. Some institutions have implemented Lean using an on-site trainer from industry. Assumptions underlying Lean thinking are: people value the visual effect of flow. Waste is the main restriction to profitability. Many small improvements in rapid succession are more beneficial than analytical study. Process interaction effects will be resolved through value stream refinement. People in operations appreciate this approach, and Lean involves many people in the value stream. Transitioning to flow thinking causes vast changes in how people perceive their roles in the organization and relationships to the product. Six Sigma was developed by Hewlett-Packard, Motorola, and GE, and comes directly from quality thinking in the 1930s. It combines established methods such as statistical process control, design of experiments, and failure mode and effects analysis, FMEA, in an overall framework with the primary aim of reducing variation in the process. Six Sigma aims to reduce variation through 5 clearly defined steps: define, measure, analyze, improve, and control. These are described here. Define. Project goals and boundaries are set, and issues are identified that must be addressed to achieve improved quality. Measure. Information about the current situation is gathered in order to obtain baseline data on current process performance and identify problem areas. Analyze. Root causes of quality problems are identified and confirmed with appropriate data analysis tools. Improve. Solutions are implemented to address the root causes of problems identified during the analysis phase. Control. Improvements are elevated and monitored. Hold the gains. For further reading, Ransom et al. Created an inventory and brief description of useful tools for quality improvement in healthcare. This inventory is provided here for your further investigation and includes flowcharts, cause and effect diagrams, statistical process control, Pareto charts, and check sheets are used to collect early information about processes in place in the healthcare setting. Basic tools are used to define and analyze discrete processes that usually produce quantitative data. These 4 help the analyst understand the process, identify potential causes for process performance problems, and collect and display data indicating which causes are most prevalent. Unit 2 of this component, Process Mapping Diagramming Tools, provides a detailed presentation of flowcharts and other process diagrams. Run chart. Run charts are plots of data, arranged chronologically, that can be used to determine the presence of some types of signals of special cause variation in processes. A center line, usually the median, is plotted along with the data to test for shifts in the process being studied. Control chart. A control chart consists of chronological data along with upper and lower control limits that define the limits of common cause variation. A control chart is used to monitor and analyze variation from a process to determine if that process is stable and predictable, comes from common cause variation, or unstable and not predictable, shows signals of special cause variation. Histogram. A histogram is a graphical display of the frequency distribution of the quality characteristic of interest. A histogram makes variation in a group of data readily apparent and assists in an analysis of how data are distributed around an average or median value. Scatter diagram. Scatter diagrams, or plots, show the relationship between two variables. The scatter diagram can help to establish the presence or absence of correlation between variables, but it does not indicate a cause and effect relationship. Management tools. Management tools are used to analyze conceptual and qualitatively oriented information that may be prevalent when planning organizational change or project management. Flowchart. The flowchart is a map of each step of a process, in the correct sequence, showing the logical sequence for completing an operation. The flowchart is a good starting point for a team seeking to improve an existing process or attempting to plan a new process or system. Cause and effect diagram. Cause and effect analysis is sometimes referred to as the Ishikawa or fishbone diagram. In a cause and effect diagram, the problem, effect, is stated in a box on the right side of the chart, and likely causes are listed around major headings, bones, that lead to the effect. Cause and effect diagrams can assist in organizing the contributing causes to a complex problem. TOG 2004. Pareto chart. Vilfredo Pareto, an Italian economist in the 1880s, observed that 80% of the wealth in Italy was held by 20% of the population. Giron later applied this Pareto principle to other applications and found that 80% of the variation of any characteristic is caused by only 20% of the possible variables. A Pareto chart is a display of the frequency of occurrences that helps to show the vital few contributors to a problem so that management can concentrate resources on correcting these major contributors. TOG 2004. Check sheets. Check or tally sheets are simple tools used to measure the frequency of events or defects over short intervals. This tool imitates the process of information gathering, is easy to use, can be applied almost anywhere, is easily taught to most people, and immediately provides data to help to understand and improve a process. Affinity diagram. The affinity diagram can encourage people to develop creative solutions to problems. A list of ideas is created, then individual ideas are written on small note cards. Team members study the cards and group the ideas into common categories. The affinity diagram is a way to help achieve order out of a brainstorming session. TOG 2004. Current reality tree. The current reality tree is commonly part of the toolkit and employs cause and effect logic to determine what to change by identifying the root causes or core problems. Another purpose of the current reality tree, whether developed by an individual or team, is to create a consensus among those involved with a problem. Goldrat, 1994. Interrelationship diagraph. While the affinity diagram can help organize and make visible the initial relationships in a large project, the interrelationship diagraph, or relationship diagram, helps to identify patterns of cause and effect between ideas. The interrelationship diagraph can help management recognize the patterns, symptoms, and causes of systems of resistance that can emerge through the development of plans and actions. It can help to pinpoint the causes of problems that appear to be connected symptoms. TOG 2004. Matrix diagram. The matrix diagram helps to answer two important questions when sets of data are compared. Are the data related? And how strong is the relationship? The quality function deployment, QFD, House of Quality, is an example of a matrix diagram. It lists customer needs on one axis and the in-house standards on the second axis. The second matrix diagram is added to show the in-house requirements on one axis and the responsible departments on the other. The matrix diagram is helpful to identify patterns in relationships and serves as a useful checklist for ensuring that tasks are being completed. TOG 2004. Priorities Matrix. The Priorities Matrix uses a series of planning tools built around the matrix chart. This matrix helps when there are more tasks than available resources, and management needs to prioritize based on data rather than emotion. A priorities matrix allows a group to systematically discuss, identify, and prioritize the criteria that have the most influence on the decision and study the possibilities. American Society for Quality, 2000. Tree Diagram. A tree diagram helps to identify the tasks and methods needed to solve a problem and reach a goal. It creates a detailed and orderly view of the complete range of tasks that need to be accomplished to achieve a goal. The tree diagram can be used once an affinity diagram or interrelationship diagraph has identified the primary causes and relationships. TOG 2004. Process Decision Program Chart. The Process Decision Program Chart is a type of contingency plan that guides the efforts of a team when things do not turn out as expected. The actions to be completed are listed. Then possible scenarios about problems that could occur are developed. Management decides in advance which measures will be taken to solve those problems should they occur. This chart can be helpful when a procedure is new and little or no experience is available to predict what might go wrong. TOG 2004. Failure Mode and Effects Analysis. Failure Mode and Effects Analysis, FMEA, is a method for looking at potential problems and their causes, as well as predicting undesired results. FMEA was developed in the aerospace and defense industries and has been widely applied in many others. FMEA is normally used to predict product failure from past part failure, but it can also be used to analyze future system failures. This method of failure analysis is generally performed for design and process. By basing their activities on FMEA, people are more able to focus energy and resources on prevention, monitoring, and response plans where they are most likely to pay off. Poka-yoke, the Japanese term for mistake proofing, means paying careful attention to every activity in a process to place checks and problem prevention measures at each step. Mistake proofing can be thought of as an extension of FMEA. Whereas FMEA helps in the prediction and prevention of problems, mistake proofing emphasizes the detection and correction of mistakes before they become defects delivered to customers. Poka-yoke puts special attention on human error. Creativity Tools. Although this group is not known as a fixed list of specific tools that would be incongruent with the concept of creativity, it typically includes brainstorming, mind maps, Edward de Bono's 1999 6 Thinking Hats, and the use of analogies. These tools help one look at processes in new ways and identify unique solutions. Statistical tools. Statistical tools are used for more sophisticated process data analysis. They help understand the sources of variation, the relative contribution of each variable, and the interrelationships between variables. Statistical process control is a graphic means used to monitor and respond to special causes of variation. Design of experiments, a wide range of statistical techniques that can be applied to both parametric and non-parametric data, allows the analysis of the statistical significance of more complex interrelationships. Design tools. Design tools such as QFD and FMEA are used during the design and development of new products and processes. They can help to better align customer needs, product characteristics, and process controls. Mistakes that are frequently made in quality improvement initiatives are mistakes in purpose and preparation, mistakes in planning and operations, and mistakes in transition and implementation. Mistakes in purpose and preparation include error number 1, choosing a subject which is too difficult or for which a collaborative is not appropriate. Error number 2. Participants not defining their objectives and assessing their capacity to benefit from the collaborative. Error number 3. Not defining roles or making clear what is expected of individuals taking part in the collaborative as faculty or participants. Error number 4. Neglecting team building and preparation by teams for the collaborative. Mistakes in planning and operations can be further broken down into mistakes in fostering a learning community focused on improvement and mistakes in transition and implementation. Mistakes in fostering a learning community focused on improvement are: error number 5, teaching rather than enabling mutual learning. Error number 6, failing to motivate and empower team. And error number 7, not developing measurable and achievable targets. A mistake in transition and implementation is error number 8, failing to learn and plan for sustaining. This concludes quality improvement methods. This unit covered quality improvement strategies and tools that workflow analysis process redesign specialists are likely to encounter in practice at clinics.